I feel like I am exponent ruled out, but whatever. It is what it is. I keep doing more videos for you guys. So we're on our last leg of these. Some of them get a little bit tricky. So I'm going to show you as much as I can how to simplify this as much as possible. So we're going to take a look. We do not want to have negative exponents at all. So with the negative exponent rule, that states that wherever our negative exponents are, they're going to be in the reciprocated spots. So if I look at this first problem right here, number 25, you can see that this right here is a negative. So what I'm going to do is I'm going to move it down to here. So what I have still up here, the 3 is still fine because that's a positive. And then the m is just going to be gone. It's going to be down here. So now you're going to have m to the 3rd and then m to the 4th. And then we're going to follow a different rule, which is the product law, stating that we can add the 2 exponents together, and then we have our answer. So in this case, this would be 3. We do m to the 3rd plus 4th, and that would be m to the 7th, and so that would be my finalized answer for that one. Now we're going to take a look. We'll do the bottom one next. So when we're doing this one, we're going to deal with, we have the 4s. The 4s are 4 divided by 4. That's going to cancel the 4s out. So we can cancel that out. Those are just going to be 1. Now this also is going to be just 1. So anything to the exponent 0 is just going to be 1. So we're going to replace this also with just a 1. So really we have 1 here times 1 here. Now this y is the only negative exponent. So we're going to bring that down to the denominator, which is only going to leave us with the z to the 3rd power up here. Now there's no other z's in here, so we're going to leave z to the 3rd up there. This y is going to come down to the 2nd power. Now there's only one x as well, so the x is going to stay there just like it is. And then we're just going to bring that y to the 2nd power down to the denominator. And that's it. Now let's take a look at these couple. So we have this one. So the 2 and the 3, we can't simplify that any more than it is. So we're just going to leave that alone. So we'll start there, kind of work our way through each piece of this. Then we're going to take a look. Now I have a bunch of negative exponents in here. So I'm going to fix that up first. So I have no negative exponents, just these x's right here. So that I can do normally. Our quotient rule states that when you have the same base, we're going to subtract the exponents. So 4 minus 2, which is going to be x to the 2nd power. So that's going to stay. It's positive, so we're going to keep it up there. And now this mess going on here. So these negative exponents, both of the y's are in the wrong spots. This needs to get down here, while this one needs to go up here. So I'm going to rewrite that first. So it's going to be y to the 3rd now over y to the 4th. So that's just reciprocating. So this is just taking the reciprocal of both of these and replacing it so that they're positive. Now I can use the quotient law and subtract. Y to the 3 minus 4, which would be y to the negative 1. That's really supposed to be up here. However, it's negative, so it needs to get put down here. So this is going to be y with a positive 1, but I'm not going to write 1 because you don't have to write that. Then we're going to look at the z's. The z is fine down here. You don't need to do anything with this. This is the only one you have to move. So we're going to take this 3. We're going to bring it down here. So it's z in the denominator. So it's 1 over z to the 3rd, z to the 4th. And then we use the addition of, we do the product law, which is addition of the exponents. So we have 1 over z 3 plus 4. So that's z to the 7th. And since it's in the denominator, it goes down there like that. And that would be my finalized answer for this one. One more quick one, hopefully. All right, so this one's pretty much positive. The only thing that I gotta move is this j up here down to here. So I'm just gonna kind of rework this, rewrite it. 2 h to the 3rd. The j is gonna go down here. So 3, we have the j already down here. And now we have another j to the third. And k is staying where it is, and a k is staying where it is up here. All right, now we go to work. 2 divided by 3, can't simplify that any more than it already is. There's no other h's but this one right up here, so that's going to stay in the numerator. We're going to follow the product rule, or we'll do the quotient rule. So this is 1 right there, so we've got 4 minus 1, which is 3. So the k has third power. And now the j's that are down here, we're just going to do the adding of the exponents. There's 1 here, there's 3 here, that's a total of 4. So it is j to the 4th. And that is my finalized answer for this. And if you want more questions like this, you may find them on my YouTube, Instagram, and TikTok, YouWantAlgebra. All of them can be located in the Exponents playlist. And don't forget to like, share, follow for more.